In the previous video I was looking at the repair of a gearbox for this Premier mower, and I was having a bit of an issue with the gears that I'd purchased from the manufacturer, and I've decided what I'm going to do is refit the original output gear. It's always driven one way, so I've looked at this under a microscope, and what was the back side of the teeth is pretty much completely unworn. There's no sign of any wear in there at all. I have polished them up, you probably can't tell, but they've come up looking like a brand new gear. And the reason I'm going to refit the old one in preference to the new one is this is quite a hard material, but as I showed in the previous video, the new gear is very soft, and I don't believe it's going to survive. This is the original shaft, and this is the new one. I've actually case hardened this just as an experiment, and it is now much harder than it was, at least on the surface, and I believe this is a better surface finish. However, I'm going to leave the new shaft unhardened, and if it wears out quickly I'm going to return it to the manufacturer. It's quite an expensive shaft, quite an expensive component. But I believe it should be case hardened around the gear teeth. They've hardened it around the splined area where the clutch plate sits, but not on the gear itself. And as I say, the original wasn't very hard either, but after hardening it, it's come up quite a hard material, so I believe it is quite feasible to make this quite a reasonable gear hardness, as they've done with the splined area, and still retain the required toughness to stop the teeth from snapping off. So that's what I'm going to do, but before I do that I've got some other tasks that I need to sort out first. So the shaft has got this kind of spigot section on the end, and that sits in one of two spigot bearings. So this is one of them. This is the part that goes on the gearbox. We've got this central spigot bearing. Now this particular one, the spigot that goes into this is the one that's still attached to the mower, but they are the same size, and we can see that they are very badly worn. And the other one that's still on the mower is about the same. They should be the same size, they're the same size hole and the same size spigot. I've measured them, and they're ½ inch, by the way, if you're interested. So what I'm going to do is machine a couple of phosphor bronze bushes. This one I can obviously make the right size. The original shaft is of course worn down, but as I'm replacing it I can make a new bush to suit the new shaft and make it the right size. I'll make the other one slightly undersized ID, just to suit the shaft that's still attached to the mower, just to make it a better fit. I could take that shaft off and grind it, but it's not really necessary. Most of the time, of course, when the mower's running, these do not turn relative to each other, they're locked together by the clutch. So it's only when it's kind of idling that it's really an issue, but I want to get this sorted out as I have these parts removed. So that's the next task. So the next question is, of course, how to get the original spigot bearing out. And there are different ways of doing this. It depends on what tools you've got, but I found the easiest way of removing bearings like this that are in a blind hole is I machine a piece of aluminium bar, so it's a nice sliding fit in the spigot bearing, whatever size it happens to have worn to, and then I fill the hole with grease, making sure there's no air in there, and then push this in and then basically hit it with a hammer, and it acts like a hydraulic ram, and in theory it should push the spigot bearing out. The sort of grease acts as a hydraulic transfer medium, and it pushes the bearing out. So I'll try that and get the spigot out. You could drill it out, but I want to get it out in one piece and also make sure I don't damage the plate. So I'll get that removed, and we can measure it up and see what we need to machine. So I got the bearing out, and I was a bit surprised. From what I can tell, looking at the parts list, This is supposed to be a split steel PTFE lined bush, and a bit of an odd choice I thought for the application. The problem with this is it's kind of exposed and gets all manner of dirt and grit and all sorts of things thrown onto it as it's running. And normally this type of bearing is gives very low friction, but has to be used in a clean environment. Otherwise the PTFE coating that's quite thin just gets ground away in a matter of minutes, and then you end up with just a steel ring, which seems to be what's happened here. And that does tend to explain the condition of the spigot. I was wondering why it was so badly worn. I thought these were going to be phosphor bronze, and what normally happens with bronze bearings is the bronze bearing will wear away, but it doesn't generally damage the steel shaft. So I do have some of these the right size, but I'm not going to use them. I'm actually going to make up a pair of phosphor bronze bushes for this application. I think it'll be a much better choice for this. And although they will still wear away because they're exposed to grit and dirt, in theory the phosphor bronze should wear away, but it shouldn't do too much damage to the spigot on the actual shaft itself. So I'll get these machined up. I'll make them a reasonable press fit in the disc. I'm not going to make it too tight because I want to be able to get them out fairly easily. And I'll bore them out slightly undersized, and then once they've been fitted, I'll bore them out to the final size. I'm doing it in 2 steps, simply because with a thin-walled phosphor bronze bush, unless I get it exactly the right size, then when I push it in, the internal bore of the bush will be reduced slightly. So if I make it exactly the right size, I'll probably still end up having to machine it out again anyway. So I'll get the bushes made. Also, these don't go the full depth of the hole, and that's fairly common. You don't really want the shaft all the way in the bush, otherwise it can wear a step on it. And then as this thing kind of moves in and out with normal expansion, contraction and movement of the machine, it can press the two apart and damage the bush, and it can kind of gall up and make it even worse. So I'm going to overhang it. I'm going to make it slightly longer than this. You can kind of see where it's been wearing, so we know how far in it goes. I'll make it a couple of mil longer, and hopefully that will be a good solution. You can see how badly worn this is. There's about probably a good 2.5–3 mil of clearance, and the one on the machine is the same. So I'll get these made up and get them fitted, and we can start reassembling the gearbox. That's the bushes turned. You might be wondering why I've made 3 rather than 2. There's obviously one of these for each of these 2 discs. The reason I'm showing this one is I tend to buy material on a fairly regular basis, and I've got a few preferred suppliers, but now and again I'll buy material if it seems like a good deal, but I always try and test it when it arrives. Now I made this one from a piece of what is supposed to be phosphor bronze of a particular grade. There's different grades of phosphor bronze, just like any other material. But I've always been a bit suspicious of this. I had it quite a long time because of its colour. It looks a bit like phosphor bronze, and it's got the kind of patterning that you'd expect from phosphor bronze. But this is a piece of what I know is the correct grade phosphor bronze for this application. And you can see they're very different colour, and even if we look at the end, you'll see they're a different colour. Hopefully you can see that. So I machined this really just to show what to watch out for. If you buy cheap material on eBay, which is where this came from, just be fairly cautious. If you're looking for phosphor bronze of a good grade for this application, it should machine like this. It'll basically make very small chips. And when I machined this piece, it machined like this. Obviously it's got very high copper content, and is not what I'd really consider phosphor bronze at all, and is not suitable for this application. It would gall up and cause all sorts of problems. So just be aware of that. If you are making components like this, make sure that you've got a good grade of material, otherwise you cause all sorts of problems and can do more damage. And what I'll do now is get these pressed in. I've made them slightly longer than the original, but it still won't overhang or rather the shaft will overhang the inside of the bush. I don't want it kind of going into a blind hole. Okay, so I'll get these pressed in. They are slightly undersized ID, and the reason for that is when I press them in, it will compress. I've made them about 0.02 of a millimetre oversized, so when I press them in they'll shrink slightly in terms of the internal diameter, and I'll then bore them out to the exact right size to suit the shaft. They'll actually be different sizes because the shaft that's still on the mower, it's a bit worn like this and is undersized by probably about 3 or 4 hundredths of a millimetre. It doesn't sound like a lot, but because I'm going to make it fit a bit better. The new shaft, of course, I'll just make the right size and it'll be a nice sliding fit because it's a new shaft. So I'll get these pressed in and we can go from there. That's the first of the 2 bushes bored out to size. This one is for the new shaft, so this should be a nice snug fit on here, which, as you can see, it is. It's actually got air trapped in there, so it's trying to pop back out, but it should be a nice sliding fit with there being very little play, which is correct. So that's the first one done. I'll do the same thing with the second one. I'll have to bore that one slightly undersized because the shaft on the machine is worn. And once I've done that, we can start reassembling the gearbox. That's both bearings bored out to the correct size. This particular carrier is the one that goes onto the new shaft, and I just need to assemble this back onto its bearings and the sprocket, and it's just a matter of pressing the parts on in the right order. Okay, that's the first hub carrier reassembled, so that now spins nice and freely. I won't fit it onto the mower just now. I'm going to put it on once the gearbox is refitted. It'll just make it easier lining up the clutch once we've got this thing realigned. But one thing I can do is, before we reassemble the gearbox, is I can use the shaft to align the clutch plate. If you've ever fitted a clutch to a car, you know that if you don't get the plate in the centre, when you clamp down the pressure plate, it kind of clamps the disc to the flywheel, which is effectively what this is. And if it's not centred, you can't push the shaft in because the clutch isn't centred with the flywheel. So I can use the shaft to do that. So just a quick word on the clutches before we get into this, and I'll let you know what I found following on from the previous video when I said the clutch plate didn't fit. So I'm getting quite a collection of clutch plates here, as you can see, and the story got a bit convoluted in the end, and I wasn't intending to change the clutch at all when I started this job. The only reason I'm having to do this is the original shaft has a spline like this to go into the clutch, and that fits on the original clutch plate, so that fits fine. But it won't fit onto the new shaft, which has a different spline arrangement. So it's the same shaft, but the splines are different. So I can't just reuse the plate that's already fitted to the machine, even though it's not particularly warm. So doing a bit of research and consulting with the manufacturer, it turns out that what I needed was the clutch plate off a Ford Fiesta Mark I. So that's what I bought. That's what this is. But unfortunately it doesn't fit. Firstly, the disc is too big. It overhangs and touches the pressure plate housing, and also this center section won't fit inside the pressure plate, so it won't actually go in. The splines fit, so it's a 1720 spline, and that fits fine, but this disc can't be used because it won't fit into this. So it turns out that it's down to kind of a mismatch between the various parts. So this pressure plate, which I have to reuse, otherwise I'd have to change the bearing and the lever and everything else, this comes off a Hillman imp. The original disc comes off a Hillman imp, but this is 160mm diameter. The one that they fitted to the Fiesta comes in two main flavours. One's 170mm, which is what this is, and they do another one that's 165mm, which is this diameter. So this is off the mower as well. So as you can see, they're nearly the same size, but the original disc that was fitted to this pressure plate was only 160mm. So the problem is that on the Ford Fiesta itself, it also uses a different pressure plate, and it can use either 170 or 165mm disc, but I can't with this pressure plate. This pressure plate will only take 160 or 165mm discs, and this one's 165. So this is a 165mm version of that disc, and it fits almost fine. It overhangs very slightly, but it does go in and it will work fine. So what I needed was a Ford Fiesta Mark I clutch disc with a 1720 hub, but only 165mm diameter. And that's what I've got hold of. So I ordered this off eBay, and this now fits fine. So it's got the 1720 hub, and that fits onto the shaft just fine. Nice sliding fit, and it fits into the pressure plate as it should, and it doesn't foul anything, so that should be fine. As you can see, it is slightly smaller than this one, but that's the two sizes that fit the Fiesta, and either one would fit the Fiesta pressure plate, but this pressure plate's off a Hillman imp, so it's slightly smaller. So hopefully that all made sense. A bit of a convoluted story. And the reason I went down this path rather than ordering one from the manufacturer is, even though I had to end up buying two, shipped, these two cost me £35. That wasn't each, that was for both of them on separate orders. Whereas the manufacturer wanted £150 for just one disc, which presumably is this disc. So just to recap, it's a Ford Fiesta Mark I clutch disc. It's 165mm diameter with a 1720 hub. So that's that issue sorted out. Now the other thing is aligning these when I bolt them back together. So this particular one will go onto the hub carrier that we just assembled. I can use the new shaft to align this before we reassemble the gearbox. I can use this as an alignment tool, just make it easier when we come to reassemble the mower. And for the clutch that goes onto the gearbox itself, rather than use the shaft that's still attached to the mower, I can actually use the shaft that came out of the gearbox, the original one, because it's going to use this clutch plate. In fact, I'll probably use the other clutch plate, it fits better. And that will, of course, mean I can use this to align this onto the pressure plate that goes on the gearbox, and again that will make it easier when we come to refit the gearbox to the machine. Well, I hope that made some sense. It was a bit of a convoluted story in the end, but we've got there, and this is the disc I need, and what I can do now is get on, I'll refit this to the carrier that we just assembled, and then once that's done we can get onto the gearbox itself. Before I start reassembling the gearbox, I just want to make sure that this fits. This is the bush that I machined slightly undersized to suit the worn shaft that's on the mower. And I didn't want to have to take this whole thing off, so we'll just try this on here. It should be quite a nice snug fit, and it should rotate nice and freely, which it does, so that's fine. This can now go back onto the gearbox. It's quite a nice fit on the shaft, so this is the second spline shaft for the second clutch, and it all should now fit together quite nicely, so we'll go and start reassembling the gearbox. It's time to start reassembling the gearbox. I'm going to be reusing the old output gear. I'm not going to fit the new one. I just don't think the new one's hard enough. I actually don't think that the new intermediate gear is hard enough either, but I can't refit the old one. It's in way too poor condition. In fact, that's the reason for rebuilding the gearbox in the first place. So to start the reassembly, I want to fit the output hub. So that's the one that the drive clutch goes onto. So that's the drive clutch that drives the main roller on the machine. And so we start off by passing the main hub through from the outside of the housing, and then there's a bearing that we have to press in from the inside, so the 4 bearings to fit. And we fit the hub, a bearing, the gear, and then another bearing, and then there's a circlip to hold it all together. And then we'll do pretty much the same thing on the other side, but we can assemble the main shaft first. So I'll get this pressed into place, and we'll go from there. As you can see, it rotates nice and freely. So the next thing is to put the gear itself on, not forgetting the key, of course. Obviously that fits in this keyway, but I need to make sure I put the gear in the right way round. So if we look at this very carefully, we can see that one side of the gear teeth are worn, so that's the ones that are facing us on the top, and if we turn it round, these are the ones that are unworn. So we need to figure out which way around this has to face. So if we turn this on its end, then this, when it's running, will turn in this direction. Let's raise the camera a bit so you can see it more clearly. So this will turn in this direction to drive the machine forward, which means the gear has to turn in this direction, and so it has to be pressed down on this side of the gear teeth, because the idler is sitting here, of course, and it needs to push this way. And so that means that looking at the gear teeth, it has to go on this way around. So all I need to do now is make sure I fit it the right way round, get it onto the press, get this pressed on, and we can then fit the second bearing. So that's both the bearings and the gear, and I've refitted the circlip onto this shaft. So that's this shaft done. This just sits in a recess in the back part of the housing. And the next thing is to assemble the main shaft, the input shaft. So that's this. We can finally take its protective cover off. And once again, you can see it's not, the gear's not as hard as I would expect it to be, so I'm a bit concerned this isn't going to last as long as it's supposed to. But what we need to do now is fit both bearings to this and then both circlips. And once we've done that, we can fit this back into the casing of the gearbox. So again, it's just pressing both parts on, and hopefully they'll go on fairly easily. So that's the bearings fitted on the main shaft. I just now need to fit the two circlips, and then this is ready to go back in, just making sure I haven't done any damage to the bearings. They seem fine. So I'll get the circlips fitted. This then passes through this housing and it goes through this way, so the spline shaft comes out this direction, and then once we've done that, all we need to do is fit the intermediate gear and its support post, and we can reassemble the two halves of the gearbox. So that's the input shaft fitted back onto the housing, and then the next thing I have to do is fit this bearing into the new intermediate gear. This can go on either way around, so it doesn't matter which way around I put the bearing in. And unlike the old bearing, this one's symmetrical anyway, so I'll just get this pressed in, and we can then finish assembling the gearbox. Good job. I was just about to press the new roller bearing into the idler gear, and this is the one they sent me. However, the one I took out is this, and this only goes, or would only go about probably 2/3 of the way through the gear, so the gear wouldn't be properly supported. So unfortunately I can't keep hanging about waiting for parts for this. I've been going around in circles for long enough. I'm going to have to refit the old one. I have flushed it out. I'll press it back in, and we'll finish assembling the gearbox and see if we've actually made any progress. Okay, I've refitted the old bearing into the idler gear. I really don't like refitting old bearings, especially one that's been subject to so much debris like this one, but as I said, I can't keep waiting for parts for this forever. So next job is to refit the idler gear. This is fairly straightforward, just a couple of thrust washers, the post it runs on, and then you just slot this into place, push the post through, and we can then put the two halves of the gearbox back together. Okay, that's all the internal parts of the gearbox refitted. And in all honesty, I'm not expecting a great deal from this. I think it's still going to be noisy. These gears are very poor quality. In fact, they're probably worst quality gears I've seen for a long time. The original seems quite good, so I've got a feeling that somebody's made a decision to cut corners or something, and I've got a feeling this is still going to be noisy. The replacement for this is £250. Over £250 for the shaft. You'd expect some reasonable quality components, but I'm really having concerns about the quality of these parts, and we'll have to see how it sounds once the entire machine's been reassembled, but I'm not holding out a lot of hope that these are actually going to be any good, but with any luck they'll at least be better than the old ones. It's fully assembled. I've refitted the coupling, the clutch lever and the clutch itself, and while it is significantly quieter, you won't be able to tell really until it's under load, but turning it like this before, it made a lot of noise. I noticed that it doesn't really come across on the microphone of the camera. You can kind of hear it growling, but these are straight cut gears, so that's not that surprising, but the kind of grunching noise has gone, but as I said, it only tended to make a lot of noise under load anyway. So it'll be interesting to see if it's improved at all. What I'll do is I'll get this refitted to the mower. I'll run it around for an hour or so, drain the oil out, refill it, and we'll have a look, see what comes out. If it comes out still as grinding paste, then we'll know that there's still an issue, but hopefully what we'll get out will be something a bit more reasonable. So the next step is to get the gearbox refitted to the machine. I won't show you that, it's just a reversal of removal. Drop this in, put the 4 bolts in, put the cross piece in, re-engage all the clutches, make sure they're properly centered, refit the engine, and then just put all the covers back on. And then we'll give it a run and see if it's any better. Incidentally, if you're interested, these are the bush types that were originally fitted to the center of the clutches. You can see there basically a metal backing with a very thin layer of PTFE, which in an application like this will last literally just a few minutes. So a bit of an odd choice. As you know, I've replaced these with phosphor bronze bushes, so hopefully they'll be a bit more suitable for this application. So I'll get this refitted and see what happens. Well, I've refitted the gearbox to the mower. Optimistically, I've refitted the covers, adjusted the alignment of the engine to make sure it's properly in line with the gearbox, and now it's time to give it a run. So the noise from the gearbox didn't really come across on the microphone of the camera, but hopefully you'll be able to hear the difference just about. It's a bit windy out here as well, so that's not going to be helping. And obviously being a diesel, the engine is going to drown out a lot of the noise anyway. But what we're kind of listening for is a loud howl that was coming from the gearbox, which hopefully has gone away. If not, this was all a complete waste of time. So give it a start and see what happens. Okay, I'll try the cutter first. That's certainly a lot quieter, and now we'll try the drive. Well, first signs are very promising. That very loud howl has gone away. Now I don't know if it's going to come back after a few minutes of use, or once I get it on a few slopes, see what happens. Obviously it's very light load here, it's level ground, but even here it was very, very noticeable before. Now it's I can't really hear the gearbox at all, so fingers crossed it's going to be okay. If there are any issues, I will of course do a follow-up video, but hopefully anyone that's interested in old machines may have found this video interesting.